Good morning, children. In today's session, we will be talking about two important reaction mechanisms of phenol. That is Reimer-Tiemann reaction and Kolbe's reaction. Okay, so let's start with it. Reimer-Tiemann reaction. First, we take phenol. To that phenol, actually, if you see, the reaction is carried out in the presence of chloroform, CHCl3, and NaOH. It is aqueous NaOH. Why we are writing aqueous NaOH? Because that should be clear, it gives Na plus and OH minus. So basically, what is the product in this? You get this OH and CHO. That means what you're getting here is salicylaldehyde. Salicylaldehyde. But now if we see the mechanism of the reaction, what exactly happens in this? Let us see the mechanism. First, what happens is you have this phenol, right? There is a bond between O and H. The reaction is in the presence of NaOH. So this NaOH will give you OH minus, right? So this OH minus will have the tendency to take this H from here. It will try to pull this H plus from here. So what will be the bond? What will happen to the bond between O and H? This bond will go back on O. It will go on O. So I hope you followed what happens. This H and OH comes out. Comes out as what? It comes out as water. And what we are left over with is this. All these bonds are intact. This is O. And you get one negative charge on O. Because that extra pair from here, that extra bond electron pair, it goes on O. It forms phenoxide ion. It forms phenoxide ion. Right? Now, let's see further what happens. Then in the next step, what exactly happens is, this is chloroform, CHCl3. Right? So, there is again, see, NaOH. So OH minus of NaOH will try to take this H from here. When it takes this H from here, the bond between this carbon and hydrogen, that electron pair goes on this carbon. And this H and OH will come out as water. This will come out as water. So what we are left over with is carbon, this chlorine, another chlorine, next chlorine, and one lone pair is left here on that carbon negative charge, right? So then we know out of carbon and chlorine is more electronegative. So this tries to take this electron pair which is forming the bond. It takes it along with it and it comes out as Cl minus. When this comes out now on this particular carbon, there are only two chlorines left over. So you are left over with one carbon and two chlorines on it, and there is one pair which is left over because that bond has gone. Now this particular carbon is having its electrophile basically, because it's now not having complete octet. It is short of 2 electrons because 1, 2, 3, 4, 5, 6. 2 electrons are less. So it's short of 2 electrons. So we can say it is electrophile. Electrophile means it is electron deficient species. It is electron deficient. So definitely it will have a tendency to, attract the electron towards itself. So this is neutral. There is no charge on it. This is important, children. Sometimes it asks what is the intermediate formed in it. This is dichlorocarbene. Dichlorocarbene. This is the reaction intermediate which is formed in Reimer-Tiemann reaction. Okay. Now, what was formed in the previous step? We will see this. It has formed in the beginning phenoxide ion. We saw this. In the beginning, there was a phenoxide ion formed with that extra bond electron pair which is there. So this phenoxide ion now further reacts with this dichlorocarbene, which is electron deficient. I have already we wrote. Now this electron pair which is on O, now it starts migrating. This and the pi bond are in conjugation. So this bond tries to come here. When this tries to come here, the carbon valency gets disturbed. So further the pi bond will shift. So when this pi bond will shift, this carbon will get a negative charge. So this carbene can attack this particular carbon atom. So what changes we did in this stage, we are going to show here. This becomes a double bond because the lone pair has come here, right? So this bond has come this side. So there is now a single bond only, and CCl2 will get attached here. And now on this I am showing the hydrogen which was already there on this particular carbon. I am showing it separately. So one hydrogen is there here, right? And this chlorine, this carbon is having now 1, 2, 3 bonds, right? So it will be still having one negative charge on it. Yeah. So what happens now is this double bond which is there between carbon and oxygen, again it goes back on this because it is more negative. It will try to pull the electron. When this goes here, this bond between carbon and hydrogen shifts here because this carbon ka valency is disturbed, and this H from here, will shift to this particular carbon which is having the negative charge. So I'm just showing what changes happened in this particular step. This has gone there again. So this is now again negative. O is again negative. This bond is intact. Sorry, this bond I did not write here. This bond is intact. This carbon is now having, this bond had gone here, means this is again a double bond. This is having 2 chlorines plus 1 hydrogen also. This hydrogen is shifted here on the carbon atom, right? Now, in the next stage, what happens is, there are 2 chlorines on this carbon. This undergoes hydrolysis in the presence of base. So 2 NaOH molecules, they hydrolyze this particular compound. So 2 NaOH molecules, they come here. This will come out as NaCl. On this carbon there will be 2 OH now. On this carbon, when there are 2 OH, what will be the product? Children, I am writing here down. This is intact. There is O, a negative charge, a double bond here. This carbon is having hydrogen and 2 OH group from the base. On one carbon, 2 OH is not stable. It is unstable. So it liberates, water molecule. Water molecule gets eliminated from here. When water molecule gets eliminated, what is the product you are left over with? CHO, right? So in the next stage, what you get is double bond, O negative, and you are left over with CHO. And in the last step, there is H plus. So in the presence of H plus, this gets satisfied and you are left over with the desired product, that is salicylaldehyde. This is CHO. This remains intact, that H plus will satisfy this, right? So this is the whole mechanism. Just see the mechanism from the beginning once again. First, this is the overall thing, what is happening. I just wrote in one step, but exactly what is happening I have explained here. Yeah, here I have explained that one step. Then from here mechanism begins. Phenol, in the presence of base, OH of the base takes this H, forms phenoxide. Next step, chloroform, in the presence of base, loses H and it forms water. It will form CCl3. Because this bond has gone here, carbon develops negative charge. Now this has gone here, this goes here because this is more electronegative. It forms neutral species now, right? Because this carbon is now deficient, so negative will not be represented. It is now a neutral species, which is dichlorocarbene, this electrophile and the sodium phenoxide will now react. So this bond, this electron pair comes here and further it shifts on this carbon negative. So this carbene will attack here. When it attacks, you will get this particular species. Then migration here of this bond goes on O, which is more negative. When this goes here, carbon valency gets disturbed. So bond between carbon and hydrogen electrons come here, make this a double bond, and this H goes on this carbon atom which is negative. So you get this species. Further, it is hydrolyzed in the presence of base. It is hydrolyzed in the presence of the base. When it is hydrolyzed in the presence of the base NaOH, on this carbon you will have two OH groups, and which is not stable. It will liberate water molecule. You will get this, and H plus की presence में you will get finally salicylaldehyde. Okay, this is the final product, salicylaldehyde. Clear? Important reaction of phenol. Next important reaction of phenol, that is Kolbe's reaction. Now the reaction is this. It says phenol in the presence of base first forms sodium phenoxide, then in the presence of carbon dioxide H plus acid medium forms orthohydroxybenzoic acid. This is orthohydroxybenzoic acid. Benzoic acid, or it is also called as salicylaldehyde. Salicylic acid. It is salicylic acid. It is salicylic acid. Okay, salicylaldehyde was formed in Reimer-Tiemann reaction. Now this is the reaction, right? But now what will be the mechanism? We are learning what we have taken this. What is the purpose of carbon dioxide? What is the purpose of H plus? To understand that, for some reactions, for most of the reactions, mechanism is proposed. So now we will see what is the mechanism of Kolbe's reaction. Now, this is phenol. OH. We have taken reaction in the presence of base NaOH, aqueous NaOH. So this will give you OH minus. Same way as we did in Reimer-Tiemann, this OH minus will take away this H. So when this goes away, it will form water, and what you are left over with is a phenoxide ion. One lone pair here, negative charge. What you get is phenoxide ion. Right, now this phenoxide ion will now react with carbon dioxide. We are using so many species, but till we understand how it is attacking, how it is reacting, it's not interesting to learn. We are likely to forget that way. So now what happens in the presence of carbon dioxide? In carbon dioxide, there is a double bond between carbon and oxygen. So oxygen is more electronegative, will try to pull the electron pair, pi electron bond toward itself, and this will try to get negative charge, and carbon will get a positive charge. So carbon gets a positive charge means now this is acting as electrophile. It is acting as electrophile. Electrophile means now it is electron loving. On the carbon atom there is a positive charge, so it is electron loving. Like in Reimer-Tiemann we did, the next step is the same. So next step, because of short of space, I am writing down. So next step, children, what happens is this phenoxide ion which was formed, there is phenoxide ion which is formed. Now this will be attacked by carbon dioxide, we said, right? So there is a lone pair of electron. This starts migrating here, and this goes here, because this carbon will now have 5 bonds. So when this gets a negative charge, this carbon dioxide will attack the species, right? So what was it? Carbon dioxide, which is now having positive charge here, negative charge here, as we have explained here. So this carbon will attack this particular carbon atom in the ring. So what you get is, what changes we made, we are going to show here. Double bond, O, single bond. This is no longer a double bond, right? So this is now a single bond only. This is intact. Here you have carbon, double bond, and when this bond has gone there means there is only one bond left over on O, on this particular carbon atom, because this pi bond has gone on oxygen atom as we have represented here. Now, I am showing the hydrogen atom separately, which was already present like we did in Reimer-Tiemann reaction, right? So again, this step is nearly the same like in Reimer-Tiemann. Again, this pi bond will go back on O. When this goes back, the bond between this carbon and hydrogen electron pair comes again to make this a double bond, because this carbon's valency gets disturbed. This is now H plus. So this is now H plus, means this will go and attack this O, and this will make it as OH. So what we are almost getting to the product. This is a single bond now. This has gone here, again a negative charge. This again became a double bond because it came here. This is COOH, right? Then we wrote in that reaction it is occurring in the acid medium. If you remember, when we wrote the simple Kolbe's reaction. So now the function is of H plus. So what will this H plus do? H plus will try to satisfy this negative charge. So what you get is our product. This is OH, and you have here COOH. What is it? Salicylic acid. This is salicylic acid, or orthohydroxy benzoic acid. Did you follow it? So now you have seen both the mechanisms. I'm just turning it like this. From the beginning, if you see, the mechanism is phenol in the presence of base loses first H plus. That comes out as water. It forms phenoxide ion. This phenoxide ion now will be attacked by carbon dioxide, where pi bond goes to O. That became negative. This became positive. So that is now attacking the phenoxide ion, and you get the species. Now in this, there is further rearrangement because this O is more negative. It will try to take this pi bond back, electron back. When this goes here, valency is disturbed, internal shifting. This comes here, H goes there. And finally, whatever H plus was there, the species was formed. That with H plus will give salicylic acid. Is it clear, children? So please learn these two mechanisms well to understand properly. Thanks for watching.